In this video, we're going to talk about 4.3. We skipped 4.1 and 4.2 in the suggested homework for this class and go straight to 4.3 with differentiating exponential functions. So let's go ahead and do that. Our first problem is not even really an exponential function. It's a constant function. And they just want you to remember that E is a constant. Like that, there's no x in this problem, so the derivative of that constant function is going to be 0. Just because you see e in a problem doesn't mean that it's an exponential function. You need to have e to a function of x here. So like in number 3, where we have y is equal to e to the 5x, and we're going to use the chain rule here. That's going to tell us that y prime is going to be the derivative of e to the 5x is e to the 5x times the derivative with respect to x of 5x is going to be 5e to the 5x. Number 5, we have y is equal to e to the 3 minus x. So that's going to be e to the 3 minus x times the derivative of e, or of 3 minus x. It's going to be a -1, my derivative that I multiply by. So my rule here says the derivative with respect to x of some function of x of e raised to some function of x is e to that function of x times f prime of x. Let's go ahead and look at our next problem here. Is number 9. We'll make some space for number 9, since it's a product rule from what I see. Number 9 says y is equal to 4x cubed e to the negative x. So I have a f of x is 4x cubed and a g of x of e to the negative x. And my f prime of x is 12x squared. And my g prime of x is negative e to the negative x. So if this is f times g, then y prime for me is going to be f times g prime plus f prime times g, 4x cubed times negative e to the negative x plus 12x squared times e to the negative x. Y prime is a negative 4x cubed e to the negative x plus 12x squared e to the negative x. And factor out a -4 e to the negative x. And that's going to be, I'm actually going to factor out a -4x squared e to the negative x. And that's going to be x minus 3 left over. I want it written that way because remember that we're interested in where the derivative is equal to 0 lots of times to minimize and maximize things, to get used to writing your final answers in factored form so that we can set each factor equal to 0 and solve. Let's go ahead and look at number 13 now. And that'll be our last one for this video. Come back and do another topic from this section. The next video, f of x is e to the x plus 1 over e to the x minus 1. And because I've already called this f, that kind of messes me up calling that f and g. So I'm going to call them u and v. And u prime is e to the x. V prime is also e to the x. So if this is u over v, then f prime of x is u prime v minus v prime u all over v squared. So that's e to the x times e to the x minus 1 minus e to the x times e to the x plus 1 over v is e to the x minus 1 quantity squared. So f prime of x is e to the 2x minus e to the x minus e to the 2x minus e to the x over e to the x minus 1 squared. And e to the 2x and negative e to the 2x will cancel. That leaves me with a derivative of negative 2e to the x over e to the x minus 1 quantity squared. All right, that's it for this video. Next time we'll come back to finding slopes of tangent lines at points. That'll set us up for being able to find the equation of a tangent line in the video after that. So now that we know how to find a derivative, use the derivative to find the slope of an exponential function at a point. Then once we know how to do that, we can find the equation of the tangent line to an exponential curve at a particular point. So come on back next time and we'll talk about finding the slope of the tangent line using the derivative for exponential functions. See you for the next video.